All right, colored pens, please. Welcome back. Happy New Year. We're going to jump right in. It might take you a little time since it's been maybe 3 weeks since we did a freshman lesson. It may take you a little bit of time to get your brain back into the game, but I expect within the next 15 minutes or so, you to be right back where you were when we left. So let's start with today's warm-up, which is all review of the last concept that we went over. So, number one, which box of cereal is a better buy, the large box or the small box? So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 confident people. Put your hands down and let's survey. I'm going to ask a survey question. I'm going to ask two different questions. The first time I'm going to say, give me a thumbs up if you think the large box. Second time I'm going to say, give me a thumbs up if it's a small box. You have to do one or the other. So there are 8, 16, there are 22 people in the room right now. So after I count all the people, it should come out to 22. So give me a thumbs up if you think the large box is the best buy. Good. 1, 2, 3, 4, 5, 6. Put your thumbs down. Give me a thumbs up if you think the small box is the best buy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Put your thumb, 13. Put your thumbs down. So I'm missing 1 or 2 students, but maybe I just miscounted. So that's pretty good. So let's see. The small box is the better buy. Now, if you took a random guess, you had a 50-50 shot of getting it right, but that's not what we want. We want to be able to explain and understand why. So we're going to get to that in a couple of minutes after I reveal all the answers. Back up for a second. All right, number 2, simple question. What's the unit rate? The unit rate. We'll start with David, Annabelle, and then Natalie.
30.
Go ahead.
34 students to a teacher.
Okay. Okay. Good, you all agree, and in fact, I'm very impressed that you all said it the way you did because that was really important. Those words are critical. It's not just 34, because that could be 34 lollipops, it could be 34 feet. It's a unit rate, so we need 34 students per teacher. If you'd like to, you can always use a slash instead of the word per, but basically, other than that, should say 34 students per teacher. Now, a higher level question. How many teachers would there have to be for the ratio to be 26 students? All right, we'll start with Annie, Chelsea, and then George.
51 teachers.
Okay. You did it. So go ahead, give me your answer. Okay. 51. Okay. So it comes out to 51 teachers. But Chelsea, don't feel bad because you're hardly the only person who did that. There's at least 2 other people in this room that did the same thing you did. And in my last class, there was a couple of people who did that as well. Now, you did a good thing. You just looked at it a little bit differently. The only problem is I did actually ask how many teachers would there be. So it's kind of implying that we're going to change the number of teachers. Okay? Good. So this was a higher level question because you had to understand how number 2 worked to then try and figure out number 3. Before we go over that, let's go back to number 1. Give me a thumbs up if you got number 1 correct. Good. Put your thumbs down. Savannah, what's the first thing you did?
Well, I did $3 divided by the 16.
Wonderful. So we've got the large box, and that was $3 for 16 ounces. And then what did you do with that?
I divided the 3 from the 16.
3 by the 16?
Yeah.
Okay, and what'd you get?
I got 19 cents.
Okay. Well, when you do the division, it comes out to 0.18, I think, 75.
Yes.
So when you're trying to compare things, you can just leave it like that. That's great that you rounded it to 19 cents. But since we're not sure what's going to happen with the small box, you can leave it as the full decimal that you get. So, give me a thumbs up if you did the same thing that Savannah did to begin with. Good. Angela, what'd you do after that? Okay, so you did the small box. And it's divided by 11.5 ounces. And what'd you get as a result? 17 cents. I think it comes out to 0.17. Anyone have the whole decimal? 3913. That sounds about right. I know it was something like that. Good. So there's a couple different ways to look at it. You can either just compare them as is, or like they both did, they rounded, and this became 19 cents, and this became 17 cents, and then you can clearly see that the small, in this case, is the better buy. Okay? Comments or questions about number 1? Go ahead, Annabelle, and then Cameron.
Well, a little differently. Like I did adding. I did 13 plus 32, right?
Okay.
It'll make $6. You'll have to pay $6. But if you buy that 2 boxes for the small one, you'll get 34.5. 34.5 ounces and $6.
That was
You
a
get
great.
more than you get.
That's a great approach. I love the thinking that you used to get to that. So what she did was she tried to find multiples, basically a common multiple of both of these, so that she could then just compare them as they are. That was a great approach. Great job. Do it again if it works for you.
I did everything right, but I chose the large box because I thought that was a better deal.
You thought it was, why did you think it was the better deal?
I don't know.
Okay. So is it just that you misunderstood what I meant by better deal, or you just had a brain moment, or?
Probably a little bit of both.
Okay. Well, I appreciate your honesty, but does this make sense now?
Yes.
Okay, good. Other comments, questions? Yes. Okay, did you get the answer correct? Okay, because you got to understand, there was a little rule that I had put in when we talked last time. Does anyone remember the little rule that applies here? What was that little rule? Cameron? Money always goes on top. Okay? Because usually you're trying to find the cost per something, per ounce, per item, per person, but the cost is going to always be on top. So I kind of did this on purpose. I wrote this question this way on purpose. I put the ounces first, then I put the money, because I wanted to see what you would do. So you got to be careful about that, okay? Good. Anyone have any other comments or questions? Questions about anything? Good. Today, we're going to explore a critical concept that we're going to be using from today, moving forward for the rest of the year. So take a moment. It's not really very much to copy. And then we're going to discuss a little bit. Today we're going to start exploring the concept of a proportion. The last lesson was a lead-in to this. You have to understand ratios and rates to understand proportions. Also, whatever career path, whatever life path you take, you're going to cross proportions no matter what. Certain careers use proportions a lot more than others, but they are prevalent in all careers no matter what. I use them as a teacher. If you're going to be a chef, you're going to see an example later of what a chef, how a chef would need to use proportions. They're used in architecture, science, pretty much engineering. They're used in everything. Because, think of this. Anytime you're going to invent something, or construct something, or design something, usually what happens is you do it smaller, to a smaller scale, and then you build the real one. If you're going to design a brand new car, you made up a new, amazing new car. You're going to first draw a small version of it. Then, once you get all the plans made, then you build the big version. That's called a proportion. It's a really complex one, but it's proportional. If you like to design toys, you're going to come up with a new action figure. Well, the action figures they come out with these days are really extremely realistic. They look just like the human body, with a little bit of exaggeration, exaggerated muscles and whatnot, but the proportions are the same. It's just smaller. They actually measure human beings and then they shrink it down proportionally. So no matter what career path you take, you're going to cross paths with proportions. So what is a proportion? It's an equation, an equality of two ratios. There's going to be a ratio on the left and a ratio on the right. And so here are 3 examples. On the left, they're all numbers. 10 over 30 is equal to 1 over 3. That's a proportion. It's a proportion because this side is equal to this side. The middle example is the type that we're going to be dealing with mostly today. And this is a proportion in which there is a missing number. And so our job here is to figure out what number must go there to make it a proportion. And there's only one number that will make it true. Some of you may already know. Don't raise your hand. We're going to talk about that in a couple of minutes. Here is a very formal example of a proportion, and this is the type of item that you will see when you study Algebra 1 Honors next year. Okay? So, we're going to talk about 2 different methods for solving proportions. I want to introduce the formal method first. And so, to solve a proportion, the first thing we do is we find what are called the cross products. I'm going to teach you what these are and how to find them. For you guys, I don't think it's going to be too incredibly difficult. After we find the cross products, what happens is we end up with an equation. Well, you guys, over the course of the second quarter, became experts, masters of solving equations. Well, these are going to be very simple ones. So you guys are going to have no problem with the second step here. I am going to use this proportion as my example. So let me just move the page up so we can see. Here we go. So, I would like to find this number. There's only one possible number. So there's a bunch of different methods, but the formal method is this. So what is a cross product? A cross product is a product of a diagonal. Product meaning multiplication. So this times that is a cross product. The way I demonstrate it is by using an arrow. So I draw an arrow from the top left down to the bottom right, and that arrow means multiply. Then you do the other diagonal, and that's the other cross product, going from the x over to the 8. And so what we're going to do is we're going to multiply from here to here, and then put the answer right here. Then we're going to multiply the other diagonal. We're going to go from here to here, and then put the answer right here. And when we're done, we're going to end up with an equation that we can solve. So let's start with the yellow highlight. 5 times 24. We don't need a calculator for that, because you can do 5 times 20 and then 5 times 4, and that's easy to do. Because everyone in this room, very high level mental math ability. So what's 5 times 24? Got 3 people who figured it out? 6 people who figured it out. 7, 8 people. Stephen? Yeah, it is a 120. So right here, following this path, we write 120. Now the green path. X times 8, well, that's pretty basic. What does that come out to? 8x, very good. So this x times 8 is 8x. And then we had an equal sign between them, and they're equal to each other. So now we have a one-step equation that we can solve. Don't solve it. We're not going to do that yet. We're going to do that in the next example, but I just wanted to show you this concept right here of finding the cross products. This is kind of a trick. I mean, in math, we tend to not call it a trick, but it's kind of a trick to finding the answer. So let's rewind a second. There was a reason why I told you not to solve it. Let's look at this again. Now I want you to look at this proportion. And I would like you to put your pencil down for 2 minutes. And I would like you to look at the proportion, and I would like you to see if you can mentally figure out, and if you already solved the equation, then you don't count. I'm talking about the people who didn't solve this. I want you to see if you can mentally figure out what number must go there. Give me a thumbs up if you figured it out. Good, put your thumbs down. Now, I'm going to write something over here on my whiteboard. I would like you to all look up here. Now I would like you to mentally see if you can figure out what x is. Give me a thumbs up. Everybody, anyone in the room, even if you already gave me a thumbs up a moment ago, give me a thumbs up if you now know what x is. It's okay if you don't. Good, a lot of people. Put your thumbs down. Very good. Don't be discouraged if you don't know, because you just didn't see what some people saw already. But I guarantee you in the next moment you will start to see it. So, Amani, what is x? Okay, what did you think it was? Yeah, it's 15. X is 15. But how is it 15? Let's look a little bit deeper. What is the relationship between these two numbers on the bottom of the proportion? What's the relationship going on there? Nancy? By? Okay, very good. Chelsea, what were you going to say? They're both divisible by 8. Excellent. Okay. Is there another way to look at it? Here, let me do something. What if I did this? What would you say now about the relationship between the two numbers? Go ahead, Annabelle. Very good. So one way to look at it is they're both divisible by 8. And when you divide 24 by 8, you get 3. And Annabelle's perspective is, well, going from the left to the right, I can multiply times 3 and I will get the 24. So let me write that down because that's actually important. Times 3. So now someone explain, how does that pertain to the top? What's going on here? Go ahead, George.
Oh, I remember when I used to did this exam with my sister. She told me that anything that you do to the bottom must be to the top.
Okay. What were you going to say, Essence? Okay. So, yeah, what George said was pretty articulate. Whatever you do to the bottom, you have to do to the top. Or whatever you do to the top, you have to do to the bottom. So, if I do this times 3, then you get the x equals 15. Let's back up here. We did the cross products, and we ended up with this. How do I solve this? How do I solve that equation? What did you learn over several months last quarter? Cameron?
JRT.
Okay, well, we're pretty advanced now, so let's skip that part. So what will be the first transformation we'll do?
Divide 120 by 8.
Pretty much. I taught you to say it a little bit differently, but yeah, we're going to pretty much divide both sides by 8. What do you get when you divide 120 by 8? Angela? You get 15. So no matter what, whether you do it using the cross product method or using this shortcut by looking for a relationship between two numbers, either way, you get the same answer. Which method seems easier to you, the cross product or the shortcut? Which one seems easier? Alexis, one seem easier to you? Shortcut, it's kind of a giveaway because I called it a shortcut. But yeah, the shortcut seems easier. So if we can use the shortcut, you should try. If it doesn't make sense to you, then don't use it. It's really up to you. You can always find the answer doing the cross products. But here's the thing. You won't always be able to use the shortcut. Real world scenarios are rarely that friendly. So, now let's get into some formal examples and start exploring these two different methods a little bit more deeply. Now, if the shortcut method makes sense to you, I only showed you one example, so we don't have enough experience to know how to determine whether we can use it or not. So what you want to do is you want to look at the top or the bottom of the proportion. You want to look at the part of the proportion that has the two numbers. So for example, that's two numbers. This is a letter and a number, so that's not where we're going to look. We're going to look here. But look at part B. The bottom has the missing number. So in this case, we would want to look at the top. So look at part A and look at part B. Can we use the shortcut for either of them? Raise your hand and give me an opinion. Can we use the shortcut for A? Can we use it for B? Can we use it for none of them? Can we use it for both of them? What do you think? Natalie? Okay, what did you think, Kiara? A, not B? Okay, so I agree that you could use it for part B, but you'd have to be like really high level, really super high level math person to figure out how to do it for part B. But it's actually pretty simple for part A. So let's look at part A, and we're not going to worry about part B yet. What is the relationship between the two numbers that I've highlighted? Dave? Good. But now think of the way Annabelle said it before, and think about the arrow that I drew. So what's another way to say that relationship? It's okay. That's okay. That's it. That's all I was talking about. You did great. So one way to say it is they're both divisible by 7. That's excellent. Another way to view it is to say, oh, well, if I multiply times 4. So now, as George said, whatever I do to the bottom, I have to do to the top, but now look at this. Uh-oh. Well, if I multiply times 4, now I have a problem because there's no number here. So what do I have to do now? Now I have to kind of shift my thinking a little bit. Alexis? Yeah, you go backwards. That was excellent, Alexis. Go backwards. So now the arrow really needs to go that way. So if we multiply by 4 this way, then we're going to divide by 4 that way. So what does y equal for part A? What does y equal? Tristan? It equals 4. Very good. Now, if you were getting confused about the shortcut, or it wasn't making sense, or you just didn't notice that 7 and 28, you could figure out what to multiply by, then you can always use cross products. Any questions about part A? So let's look at part B, and we already explored this a tiny bit. We already looked here, and I tend to agree with Kiara that you could find a shortcut for it, but it would be a bit of a challenge, and it might end up being more work than just doing it using the cross products. Keep it. You use it. We'll get to it in a moment. But let's say that you can't find a shortcut. I can't, I'll be honest with you. So I would just do cross products, and so that's what we're going to do here. For the purposes of this lesson, we're going to do cross products. So 20 times 28, and the result is going to come right here. 20 times 28 you should be able to do mentally, because you could do 2 times 28 and then add a 0 on the end. So what do you get? 20 times 28. If you can't do it mentally, then pick up your calculator. Essence? Say it again. Very good. 20 times 28 is 560. Equals, and now do the other cross product. 70 times b, we've figured out with Annabelle's help, that's easy, it's just 70b. How many steps do we have to solve this equation? How many steps are there? Angela? Yes, a one-step equation. I mean, think about it, that goes way, way back to that first poster in the back of the room. So how do we solve this one-step equation? How do we solve it? Cameron?
Divide both sides by 70.
You said that beautifully. Divide both sides by 70. This disappears, and we get b equals what? B equals what? Yes. Tatiana?
8.
8. Very good. Does anyone have any questions? Okay. Nolly, what was the shortcut that you found?
You can use A because we're both 28, and then 20 plus 70 is like 3.5. So then 3.5 plus 3.5 is 7, so you already have that. You just go
Okay. I followed you, but hold on a second. The multiplying number is what? You said 3.5. So if you were trying to find a shortcut, it doesn't have to be a whole number, but we could multiply by 3.5 to get from here to here, and then we would do the same thing on the bottom, but unfortunately we'd have to go backwards, so you'd have to divide by 3.5. The hard part is figuring out the 3.5. If you can do that just because your brain kind of sees things that way, wonderful, do it. I think that's pretty hard. My brain isn't able to do it at that high a level. So if I can't do it that way, I'll just do the cross products because I don't think that's that hard either. Okay? Annabelle? Right, and that's why some people are able to do that because you can see things that way. I agree. Okay, not everyone can see things that way. That's a really good point. And I like what you said, Nolly, about doubling it and realizing that going backwards, you would basically be halving it. Right? That was good. I like that. Okay? But that's hard for a lot of people to see. That's why I didn't want to really talk about it too much. Okay? Good. We're doing extremely well. So let's look at one more. So, give me a thumbs up if you feel comfortable using the shortcut with this proportion. Thumbs up if you feel comfortable using a shortcut. Good. If you feel comfortable, go ahead and do it. I personally, most of us did not. I think one or two people put their thumbs up. I do not at all. Because if you look at these two numbers, finding a relationship between the two is extremely difficult. So then we just resort to cross products. So multiply here, and then multiply here. 52 times 9 is not hard. 50 times 9, and then 2 times 9, and then add them together. So what do you get? 52 times 9. I see people resorting to their calculators. Come on. You can do it without a calculator. David, go ahead.
It was 460.
Close. 460 missing.
It's 468.
What'd you say?
I said 468.
Oh, 468? I thought you said 460. Yeah, you're right. 468. Sorry, Stephen. I know you were waiting to. I thought you said 460. It's not a big deal. All right, so yeah, we have 468 equals 8m. And Angela, how many steps is that going to take us? One simple little step that Cameron explained several times already. And so we just divide both sides by 8. And so what do we get for the value of m? Kiara, what'd you get? Alexis, what'd you get? Yeah, you get 58 and a half, or 58.5. Comments or questions on how we did this?
Could you round this? Like,
It kind of depends on the situation. Rounding 58.5 is totally unnecessary. Remember, sometimes rounding is used because of what we're looking for. Sometimes we round things because the decimal places get too long and it's kind of a waste. With one decimal place, it's not like it's hard to write down 0.5, so you might as well just write 58.5. Unless I said round to the nearest whole number. Okay? Nali, you had another comment? You have to hold on. Okay. So, now we're going to go to a checkpoint, but we're going to do it differently than we've ever done before. So everyone put your pencil down on your desk. Here's checkpoint number 1. Now, I'm going to teach you a procedure, some new procedures for my room. And we're not going to use it every day, but we're going to use it more frequently, hopefully a little bit more frequently. So, behind you is a stack of whiteboards. Nali, behind you is a stack of whiteboards. And Annabelle and Adriana, behind you guys, there's a stack of whiteboards. Let's start with this group over here. Annabelle's going to grab 4, and Adriana's going to grab 4. And they're going to each take one for themselves, and then they're going to just gently, without accidentally on purpose banging someone's head, pass the other ones forward, and everyone's going to end up with a dry erase board. So, Nali and DeAndre, if you guys can each grab 4. Tristan, you only need 3. Cameron, you only need 3. Well, there was 8 there before. Oh, no, I think I took one. That's fine. So you guys need 2.
yes.
Here we go. Now, at the beginning of the year, listen carefully. At the beginning of the year, I asked you to get listen to me. The beginning of the year, I asked you to get a dry erase marker. We're now halfway through the year, and we never used it. So I would not blame you if you don't have it. So don't worry about it. But I would like you to look. If you have one of your own, please take it out. If you don't have one, don't worry about it. I have one for you. If you have your own, please have it out so it's easy for me to see. Now, a note about dry erase markers. First of all, they are expensive. Not ridiculous, but they're much more than a regular pen. So we don't want to waste them. So, they dry out just like markers do. So first of all, if you're borrowing one of mine, you have to be extra responsible. When you use it, of course, take the cap off, use it. But when you're done, put the cap back on until you hear it click closed. Otherwise, it will dry out. If you do it like this, it will dry out. That's not closed good enough. You have to click it closed. So do not dry out any of my markers. Also, do not push too hard. It actually does not take a lot of force to have these right, and if you push too hard, the point goes into the marker, and then it becomes a complete waste. So you do have to be a bit gentle and be careful. Okay? So, who needs? You both need? You, one for you. One for you. You got it. Good. You have.
Thank you.
Sorry. You got. Remember, if you have one of mine, I'm not coming to hunt for you. All right. Now, here's how it's going to work. You are going to do the entire checkpoint on the board. Now, writing on a whiteboard is different than writing on a piece of paper. I've been doing it for a long time, so it's not hard for me. This might be your first time, so it might take a little bit of practice. But when we write with, make sure you're with me. When we write with a pencil, the way we do it is we put the bottom of our hand on the table, and that serves as kind of I can't even think of the right word, but a support for the pencil, and then we write like this. So here's what it looks like on the board. I'm going to write my name doing that. I'm going to put my hand on the board and now write my name. When I put my fist on the board, it limits how far I can write. This is way too small. Look how big the board is. It's kind of like me doing this. What's the point? People in the back can't see that. So we want it to look like this. There's a big difference. And so you have to learn how to do it more like an artist. An artist does not use the bottom of their hand to paint. So you have to think of it more like this instead of like this. So you have to actually extend the pen a little bit and then you draw. It does take some getting used to, but that's how you write a little bit bigger. So it's not a big deal if you write too small this first few times. But by the end of this week, you should be getting used to how to write a little bit bigger. Okay? Any questions about that? Also, you might make a mistake. You need something to erase with. A paper towel actually works perfectly. So I'm going to give each person a paper towel. If you take one and pass the rest behind you, everyone will get a paper towel to use as an eraser. You will throw out the paper towel at the end of class in the garbage on the way out the door. Yes. On the board, so they will not be in your notes because it's supposed to be a mini quiz for us to see how well you're understanding the concept. So it's okay that it's not going to be in your notes.
Is it alright, like, after we get the answer right, can we write it in our book?
If you want to, but you absolutely do not have to. Okay? I would not expect my students to do the same thing twice. That's not really fair. Okay, so let me help you get set up. This checkpoint has 2 questions. So how can we fit 2 questions? We are going to hold the whiteboard landscape, which means this way. So everyone hold the board on your desk this way. And now, taking your dry erase marker, what I would like you to do is make a dividing line approximately straight down the center, like that. Doesn't have to be perfect. And you are going to have a question A and a question B, so watch what I do. I put a little A in the upper left-hand corner there, and I'm going to put a little B up like that. Okay? So question A looks something like this. Okay? Adriana, can you read that? Okay. So that's because look at all this space here. This is way too small. So, again, it's going to take you some getting used to. You might have to erase your work a minute, 1 or 2 times, but here's what it should look like. Can you read that?
Yes.
Okay, so that's easy to read. And the idea is for me to be able to see your work from all the way up here, I should be able to see everybody's in the room. So this is what I'll be looking for, okay? So, anyone have any questions? So I'm going to reveal the checkpoint. I'm going to give you a little bit of extra time than I usually do. And your job is to just finish the checkpoints on the board. Okay? Here, checkpoint number 1, part A and part B. You got 2.5 minutes. Make sure when you find the answer to circle your answer very clearly so it's easy to see. Circle your answer. And part B. It's small. See all this space here? You want this to explode and take up that much space. And don't erase it, but do better on this. That's good. Beautiful. Good. That's perfect. Perfect. Perfect.
Yeah.
Good. Excellent. Excellent. Very good. Nice. Good. When you're done, circle your answer so it's easy to see. Very good. You don't need to write it down. You just need to do All right, so you should be done. Now, I'm going to teach you how to present your board. That's the whole point of doing this way is to present your board. So I'm going to teach you how to do that. I'm going to use this row all the way over here. Everyone's going to watch how we set it up, and then you're all going to do it. Do not at any point erase your board. Do not do anything about erasing until I tell you to. All right. So now, Natalie is at the front. She's going to put her board right on her desk, and she's just going to put her hand right up there and hold it. Okay? So she's holding hers. Now, if Cameron does the same thing, then unfortunately, Natalie is blocking part of his board, so I won't be able to see it. So Cameron is going to put his hands on the side and hold his up a little bit. And then Essence, also, if she just holds it up like this, or like this, then Cameron's going to be blocking it, so Essence is going to hold the sides and hold it up a little bit higher. And then Adriana, being all the way in the back, you can move yours down a little bit, and that's good. No need to get up. Cameron can lower his a tiny bit. But if you look at it, it's kind of like a staircase of magical math. So now, all my students in the rest of the room, you need to set up your row just like they set up theirs, and keep your board up as I go around and figure out who's understanding and who's not. Okay, put your boards down and turn them so that they are facing you again. Do not erase your own board until I say the words, okay, now erase your board. Do not erase it at this point. You don't know whether you got it right or not. But I can say that 19 people in the room got both of them correct. 19 people in the room got both of them correct. So now look up here to see if you are one of the people who got all of them correct. Do not start erasing your board because I'm not done yet after I reveal the answers. So part A, W equals 45. Part B, Z equals 40.
I'm a failure.
So now, another benefit of the boards is I can now use your work to demonstrate different ways of solving the problem. So, Annie, if I could borrow yours for a moment, please. So here's a very good example of how to draw up a board using the space nicely, and then you can also see her method is very clearly demonstrated. She clearly understood she's going to multiply by 3 and then multiply by 3. And then she figured out multiply by 5, multiply by 5, multiply by 5. So we can all see that she used the shortcut method and she did it correctly. Okay? So great job. And I saw a lot of people who did that. Now, look at Fancy's. And again, very good use of the space. Fancy did it a different method. Fancy did cross products. And she also got both answers correct. So you can clearly, I don't know, Stephen, can you see from where you're sitting? Can you see what she did? Yes? You can see it clearly? Okay. So you can see, look at the equation that she wrote right here. 225 equals 5W. She didn't write how she solved it. I wish she would have, but that's okay. She clearly solved it correctly. And then she did it again here. 11Z equals 440, and got Z equals 40. So I can see two different methods being used in the room, and I can figure out who did it right and who's still struggling. Now, 19 people got both of them right. The other people got one of them right. Some people got the first one wrong because you got tricked. You got tricked because of the numbers look tricky. Okay? So, does anyone have any, do not erase your board yet, does anyone have any questions on how to do this? Okay, now listen carefully. You are going to use your napkin and you're going to erase, don't do it yet, watch first, erase the board and then lean it against the leg of your desk or the leg of your desk over here so it's out of the way. So go ahead and do that. And then we're going back to your notebook for example 2. discussing it. Finish my assignment, my task. Good, perfect. All right. Now you're back to your notebook. That didn't go anywhere. You just were. It was underneath the board. Example 2. You do not. For today, you do not have to copy the whole exam. You need to write example 2, part A, and then you need to read carefully. And then we're going to do something together. Of course, you have to read. Okay, so we have this awesome character named Theo. He's going to be the character for this first question. He's a good guy. He's trying to bake some cookies. So he's an aspiring chef. So chefs who, it doesn't matter whether you specialize in baking or traditional meals or whatever, it doesn't really matter. You're using recipes constantly. And you constantly are changing how many people the recipe is going to serve. And to do that, you use proportions. Anytime you are taking something small and blowing it up bigger, or taking something big and shrinking it down, for it to be accurate, you are using proportions. For example, you draw a floor plan of a house, then you build the actual house. The floor plan is tiny on a piece of paper. A real house is humongous. The floor plan is small, the house is big, you use proportions to do that. I referred to action figures earlier. If you take a large, like a wrestler, they make action figures out of wrestlers, a humongous person, and then you want to shrink them down into an action figure that's 6 inches tall. Well, how big does their arm need to be in relation to their leg and their head for it to look normal? You can pick whatever you want and they would look like a monster from another planet, but if you want it to look accurate, then we use proportions for accuracy. So Theo has a cookie recipe that makes 36 cookies, but he wants to change it. He doesn't need 36 cookies, he wants 24. The original recipe calls for 2 cups of sugar. How much sugar should he use in his recipe so that they will taste the same? I mean, he can put whatever amount of sugar he wants in it, and it might taste okay. But for it to taste the way it's supposed to taste, it needs to be proportional to the original recipe. Okay? So we are going to set up a proportion with the information, and then find the missing piece of information for Theo. Okay? Labeling is incredibly important when you're using proportions in the real world. There are a couple of different ways to label. You can either label the whole left side here and the whole right side, or you can label the top and the bottom. No matter what, you want a couple of labels to help you keep the information straight. Because setting up the proportion requires accuracy. So for example, we could call the first recipe the original. So I could write original here. So go ahead and you can write that down. And then he's trying to change it to a new recipe that makes a smaller amount. So what pieces of information apply to the original recipe? What numbers apply to the original recipe? Tristan?
36 cookies and 2 cups of sugar.
Very good. Now, I can put, this is the original. The original is going to go here. So I can either put the 36 and the 2, or I could flip-flop it and I can put the 2 and the 36. It actually does not matter. What matters is, will my other side match this side? So that's where the other way of labeling is also important. If I say this is the 36, then what I've just said is this is the number of cookies going across. Going across the top is the number of cookies, and here is the cups of sugar going across here. If I flip-flop it, that means the top is the sugar and the bottom is the cookies. It doesn't matter. You have to stay consistent throughout the proportion. So here's what I mean. We have this other number, the 24. With it set up like this, where does the 24 go? Catalina?
On the top.
That's right. It has to go on the top because the 24 represents a number of cookies. If I put it on the bottom, then I'm saying 24 cups of sugar, and that's not what it is. So here's an example that would be wrong. If I put 36 over 2 equals n over 24, that would be incorrect. That won't work. So where I put the information is important. So now I have the missing number right here. I need to know the number of cups of sugar from my recipe of 24 cookies. So now we're ready to solve, and we can solve it any way we would like. We can use the shortcut. We can use cross products. Give me a thumbs up if you're comfortable using a shortcut for this one. Thumbs up if you're using a shortcut. Okay? Good. If you're comfortable using a shortcut with this, go ahead and give it a shot. I think it's pretty difficult, so the rest of us are going to use cross products. Multiply diagonally here, and we get 36n. Multiply diagonally here, and we get 48. And now we have a simple one-step equation to solve to find the number of cups of sugar. Divide by 36, divide by 36. And what does n amount to? 2 people figured it out, 4 people, 6 people, 8 people. Alexis, what'd you get?
I have
Okay, Savannah, what'd you get? Just 1.3 exactly?
No. Well,
What's the right word for that? She's right, but there's another technical word for that. Stephen? Well, that's also somewhat inaccurate. What is it really, Adriana?
1.3.
Yeah, it's 1.3 repeating. So this is how you write that, with a bar notation. But in the world of cooking, give me a thumbs up if you're an amateur chef. Thumbs up if you're an amateur chef. Nobody knows? Okay, so nobody in the room? I got one amateur chef? Okay. The problem is not understanding the thumbs up system. That's okay. So we've got a few amateur chefs. My amateur chefs, do any of the measuring tools that we use in cooking have repeating decimals on them?
No.
What do they do? What do they have on them?
fractions.
Fractions. So could someone tell us what is 0.3 repeating as a fraction? Everybody in the room should know. Right, instantly off the top of your head. 0.3 repeating is what fraction? Go ahead, Adrian. Well, 3/10 would be if it was exactly 0.3. So if it was 0.3, 0.3 is 3/10. You are absolutely right. What is 0.3 repeating? That's different. So hopefully if you did not know, you will know after the next 5 seconds. Steve? It is 1/3. That's what 1/3 is. So in the world of cooking, you would not ever ask someone to do 1.3 repeating cups of sugar. Doesn't make any sense. But a chef would understand this. 1 1/3 cups of sugar. And so that is the answer to the question. 1 1/3. There are no decimals on any of the measuring utensils, or at least none of them that I've ever used. There may be some out there, but fractions is what everyone uses. Okay? So, comments or questions on how we did this? So, some key things. Setup was the whole thing. Setting up this proportion was the work. That was the whole point of doing this question. Once we have it set up, this part should now be pretty easy for you. So this is what we're learning now. Okay? Tristan? No. 2 over 36 equals, you have to flip the whole thing. Then the 24 would have to be on the bottom here. That's the whole point, is that where are cookies now? If you put the 36 cookies on the bottom, that's cookies. The 24 has to be on the bottom now. So what you just illustrated is what you're not allowed to do, is put the numbers wherever you want. Okay, so let's look at another example. This time, instead of Theo, we've got this awesome guy named Spencer. And so, Spencer is a working man, and Spencer earned $112 for 8 hours of work. At this rate, how much will he earn for 45 hours of work? Now, there's quite a few different ways to solve this. But today we're learning about proportions, so today we're going to learn a proportion method for solving it. If you can come up with other methods, in the future you can use whatever method you would like. But we're first given that Spencer earned $112 for 8 hours. That's a rate. So let's write that down. Spencer earns $112 in 8 hours. Now, if I write it like that, that means I just established that the top is money and the bottom is hours. And so now when I actually add in the proportion, now I know where everything goes. The other piece of information is the 45. The 45 represents a number of hours. So where does it have to go? There's only one place it's allowed to go. Alexis? It has to go on the bottom because I've now established that hours is on the bottom. Now what Tristan was asking a moment ago is, well, can I flip it? Yes, you can flip it, but then you have to do it right. You can put the 8 on top and the 112 on the bottom, but then that means the 45 has to go on top here. And that's going to be the missing number. You have to put things in the right place. You cannot just put them wherever you want. Okay? So let's go back to our original. And so there's the missing number. So give me a thumbs up if you feel like you could use the shortcut to find this one. Good. If you feel like you could use the shortcut, go ahead and give it a shot. The rest of us are going to use cross products because I cannot use the shortcut. So we're going to do the cross product here. And unfortunately, this time I cannot do mental math myself. Maybe you can. I tried earlier and it was just a little too much. You could do 100 times 45, 10 times 45, and then 2 times 45. You could do it. It's a little bit too much on my brain, but... So go ahead and do 112 times 45 using your calculator. What do you get? DeAndre?
5,040.
Yep, you get 5,040. And then the other cross product is n times 8. You get 8n. Now solve the equation. Divide by 8, divide by 8. And so, how much money will Spencer earn for 45 hours worth of work? Cameron, how many did you get?
$630.
Okay, what did you get?
$630.
Yeah, it comes out to $630.
Easy.
Comments, questions, concerns? Annabelle, yes.
All that, well, I didn't do the short comment, but, all that we did was, divided by 112, and I got, $14 per hour, and then I just like 45 cents.
Right, and like I said, I said before we even started the question that there's a bunch of different ways to do it. That I just wanted to introduce the proportion way of doing it, and then in the future you can use any method you would like. But that's one of them. Very good. So the idea here in this example was to learn how to write the proportion and then solve it. Does anyone have any questions on how to write a proportion?
Not really, but I did it the shortcut way, and like I kind of got 8 times 5. Oh, never mind. I messed up.
Okay. I'm glad you discovered it. All right, to the boards. Pick up your board. Now you have one question that's going to take over the entire span of the board. One question. So read the question. You do not have to copy it down. You don't even have to write checkpoint. But you do need to solve. And you got 2.5 minutes. Okay, so from now on, the bell rings, you just put the board up the way you were taught. That's it. Whether you're done or not. Okay, put your boards down. It's a little hard to tell. Some people's handwriting needs a little work, but as far as I can tell, there were 19 people who got it right. Do not erase your board. Put your board down in front of you. The correct answer is 4.5 days. 4.5 days. So, let's see who's got a nicely written example. Let's see. That's pretty good. Here we go. So this is a pretty good example of what it should look like. So you can see the original proportion set up correctly. That was the first part. That was actually the hard part. Making sure the numbers are in the right place. You got miles and miles all going across the top. Cross product, and notice the arrow, and then right there is the result. Cross product, and then you can clearly see him solve the equation, and he got the right answer. Make sure when you write your answer, you write the unit of measurement. So it was 4.5 days, you should have written 4.5 days. How do I know you didn't mean hours or minutes? You have to make sure you write the correct unit of measurement. Okay? Okay, any comments or questions on how this was done? Essence, David, and then George. You sure? Okay. 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 Did it work? Okay, so when you say another way. Okay, George?
I did it the shortcut.
Okay, what shortcut did you discover?
1875 divided by 1250 and about 1.5.
Okay,
And then I did to instead of dividing 1.5 to that, I
multiplied. Very good. Excellent job. Excellent job. So you just discovered something on your own. Excellent.
Like I just wanted to try it.
And it worked. And the way you did it will actually work every time. So that's really good. Okay? Good. Any other comments or questions? Good. If you would erase your board, please, and lean it on the leg of the chair. And back to your notebooks, your classwork. Draw a line across your paper. Your classwork is in textbook, page 288. You're going to do numbers 13, 15, 17, 19, 21, 23, and 27. All right, here are the solutions for 13 and 15. $17 and $19. $21 and $23. All of these, you could have used the shortcut or cross products. And then number 27, which is where most of the thought was involved, had two parts. Part A, you were comparing the rates, and the answer is no. did not have a greater number of goals this season. He had a greater number of goals last season, so the answer to the question is no. Part B, Part B, you had to write a proportion, and it could have been this proportion, it could have been the same thing except flipped over, but no matter what, you should have gotten 40 goals. Yes, Annabelle.
I didn't guess A, so he picked the first is only 9 games.
That's right.
So that's
That's right. But think about the question during the warm-up, where you had two different quantities of cereal. One box was large and one box was small. What did we do to compare them? You had a method that you came up with to compare them, whereas you multiplied till they were equal. So that was the same thing you should have done here. Okay? All right. So draw a line across your paper. Your homework is in the textbook, page 288, numbers 10 through 32 even. Number 30 and 32 are the most important questions on the assignment. 2 out of the 12 should take you longer than the other 10. Numbers 30 and 32 should take you